Hi, my name is Jason Shaw. I'm a technical marketing architect with VMware, and in this recording, I'll be presenting the NSX-T Federation collateral that's been added to the Cloud Foundation 4.2 Deep Dive. Now, this section of slides will provide details of the NSX-T Federation support with Cloud Foundation. Let's start by talking about some of the use cases. NSX-T Federation guidance for Cloud Foundation supports the following use cases. Operational simplicity, where administrators can register and then control multiple NSX deployments from a single interface. This capability provides a single pane of management for multiple deployments and simplifies administration. The remaining use cases have a global impact, as indicated by the G in the icon. These are common policy configuration, where administrators can use the Global Manager UI to create a security policy, such as a firewall rule, and then push the configuration to one or more local managers. This capability reduces administrative burden and minimizes the opportunity for human error. Or global networking, where customers can create global networking objects such as routers and network segments that have the option of spanning one or more sites and providing failover and failback capability. Global networking is key to simplifying network designs and to building a disaster recovery solution. Now, NSX-T Federation is a capability within NSX-T that enables administrators to manage multiple NSX-T deployments, create global networking with failover capabilities, and enable disaster recovery solutions. Now, here we see an environment without federation. Multiple infrastructure deployments, each with an independent NSX deployment for managing network and security configuration or policy. These are isolated NSX instances. The customer has 3 different interfaces to manage. NSX-T Federation includes a new component called a Global Manager. As its name and the G on the icon suggests, this component is deployed as a cluster that has a global reach and manages one or more local managers. A local manager is simply an NSX Manager instance at a specific location that is participating in an NSX-T Federation. Now, once an NSX-T Global Manager cluster is deployed, multiple NSX-T managers can be onboarded. Within the context of federation, these NSX-T managers are referred to as local managers. Now, please note that these local instances are illustrated by the L on the icon in this presentation. A local manager, or LM, is defined as an NSX-T manager system in charge of network and security for a location. If you have a workload domain in Cloud Foundation, it may have a dedicated NSX-T instance or perhaps shares an existing NSX-T instance. That instance is considered an LM once registered or onboarded into a global manager. Now, after implementing a global manager cluster and registering existing NSX-T managers, i.e. local managers, customers benefit from a central view of network and security, configuration, and policy across these multiple sites. That global manager provides a single pane of management. For high availability and to recover from a failure of the global manager, a standby global manager cluster can be deployed. This standby cluster should be deployed in a different availability zone, and it will receive a copy of all configuration changes made on the primary cluster. Only one global manager cluster can act as primary at a given time. In the event of a failure, the standby global manager can be manually promoted to primary in order to continue providing NSX management. The inactive global manager cluster, or the standby cluster, is shown grayed out in this presentation. A key capability of NSX-T Federation is the ability for an administrator to create network and security configurations from a single interface and then push these configurations out to one or more local managers. Administrators can create networking components such as logical routers and network segments, or create network services such as firewall rules, network address translation rules, DHCP, VPN. Now, another key capability of NSX Federation is the ability to create logical routers and network segments that span locations. The ability to create global networking across sites is a key component in building a disaster recovery solution. With common networking across sites, disaster recovery can be simplified as protected workloads can be recovered on another site without needing to change the IP addresses. Now, when implementing NSX Federation, an additional network is required to carry what's referred to as RTEP traffic. RTEP stands for Remote Tunnel Endpoint. This network is used to carry Geneve encapsulated traffic across locations. RTEP interfaces are instantiated on the NSX edge nodes in each location and carry traffic between sites. Now here's a detailed view of the control plane architecture for NSX-T Federation with Cloud Foundation. The VVD guidance for manual deployment of NSX-T Federation with Cloud Foundation 4.2 describes a dual region deployment. In this architecture, the control plane has an active-passive architecture. Here you can see a 3-node primary global manager cluster deployed into region A and a 3-node standby cluster deployed into region B. All operations are to be performed on the primary global manager, which will replicate configuration to the secondary global manager, ensuring that configurations are in sync. The local managers or NSX manager instances in each region are then registered to the global manager. Here's a detailed view of the data plane architecture for NSX-T Federation. Now here you can see a global Tier 0 router deployed that spans both regions. This router will provide north-south routing for all traffic in the federated deployment. Each region will have a region-specific Tier 1 router deployed where local segments can be created and attached. And in the event of a region failure, it is expected that these segments will be unavailable. Now for workloads that require global connectivity, a Tier 0 router is deployed that spans both regions. This router and any connected segments will have failover capability. Here's a view of traffic during normal operation where both regions are available. So you've got that global Tier 0 router configured active-active with edge nodes residing in each region and is configured primary for each site or region. This Tier 0 configuration actively routes traffic north-south in each region simultaneously. The region-specific segments are routed east-west to other attached segments using their attached Tier 1 and with north-south routing provided by that global Tier 0 with edge nodes that reside in each region. Multi-region segments are connected to the multi-region global Tier 1 router, which again spans both regions. This Tier 1 router is configured with a primary location in region A and a secondary location in region B. In normal operation, all north-south routing from segments attached to this multi-region Tier 1 are performed through the Tier 0 in region A, as depicted in this graphic. Now, in the event of a failure in region A, all traffic that would normally egress via region A is impacted. The region-specific segments in region A are impacted. All multi-region segments that physically reside in region A or B are impacted. And the global control plane is also impacted. Failover in this NSX-T federated architecture is manual by design and requires 2 actions. The standby global manager must be promoted to primary, and the multi-region Tier 1 router must be reconfigured to use region B for north-south routing. Let's take a look at network failover. Now, once the global manager has been promoted to primary, an administrator can now reconfigure the multi-region Tier 1 router to be primary for region B and to route north-south via the region B side of that Tier 0 router. Once this is accomplished, multi-region workloads residing in region B may now resume communicating north-south through the Tier 0 router. Now, once region A is recovered, network failback will not occur automatically. If failback is desired, 2 manual actions will need to take place. The standby global manager in region A will need to be promoted to primary, and that multi-region Tier 1 router will need to be reconfigured to be primary in region A and secondary in region B. Great, now here are several important considerations relating to awareness, monitoring, and compatibility. Now, when implementing NSX-T Federation into a Cloud Foundation 4.2 deployment, as the NSX-T Federation is manually deployed using VVD guidance, VCF does not have an awareness of federation. It's important to consider this when performing workflows relating to the NSX-T components, such as lifecycle management, certificate rotation, or password rotation. It's also important to note that vRealize operations and vRealize automation also do not have an awareness of NSX-T Federation today. Now, monitoring of system log files and performance statistics are an important part of ongoing system maintenance. For log file monitoring, it's important to note that vRealize Log Insight licensing is included with NSX-T Enterprise Data Center licensing. For performance monitoring, although VROps is not global manager aware, the performance of each local manager can be monitored using VROps. And regarding product compatibility, it's important to note that with NSX-T 3.1, Site Recovery Manager does not currently support using VM tags. Additionally, as mentioned earlier in the deck, the process of registering a local manager or onboarding is only supported for greenfield or newly deployed NSX Manager instances. The onboarding of brownfield NSX Manager instances have some known incompatibilities with certain configurations. And some examples include where network address translation, VPN, or load balancing are being used. Customers will need to open a ticket with GSS if brownfield onboarding is desired. Now, this concludes this presentation, and we want to thank you for watching.